Okay, today it's the last Bash lecture, and then we move on to C in the rest of the course. So this is basically an odds and ends lecture. So it's everything that kind of didn't fit in to the somewhere convenient in the earlier lectures. So I just threw it all in at the end. All right, the first command we want to talk about today is called tr. So that's the command that translates, squeezes or deletes characters from standard input, and it writes it to standard output. So this is basically a character-based search, right? So you don't use this when you want to replace entire substrings. Right? If you want to go into a string and replace individual characters of the string, this might do the trick for you. So how do you use it? So there's tr, that's the name of the command. There are some options. We're only going to look at one of them. And then you specify a set of characters that you want to translate from, right? And what those characters should translate to. Right? So from and to, they're supposed to be sets, right? In other words, they're supposed to contain only unique characters. But the program doesn't actually check if your sets are unique. Okay? So you have to be a bit careful about that. So for example, now remember this is character by character translation, right? So you can only translate one character to another character. So here we've got the string sparring with a purple porpoise, right? Lots of P's. Right? I want to replace every P with a T. So the way you do it, you can just pipe. I can echo the string and pipe it to tr. Right? Tr reads standard input, right? So it'll take the output of echo, right, and read that. P, that's my set of characters to translate from, right? And T, that's my set of characters to translate to. Right? So when you run this, right, so there's the command. When you run it, not surprisingly, every P changes to a T, and you get starring with a turtle tortoise. Right? So character by character translation. So that does one character. Right? Here's another example where you can replace one character with another. Okay, that thing there, right, ca.queensu.cs.CISC220, that's a package name in Java. Right? So that's a Java package. Now, the Java compiler expects any class that's in this package to be in a directory called ca/queensu/cs/CISC124. Right? So if you want to write a bash script that can read a Java program to find out what package it's in and then compile it, right, you need to tell it where it can find that program. Right? So in other words, you need to take that package name and replace all the periods with a slash to get the directory that the file should be in. Right? So what does that do? Now somewhere I've got these all. There's a lot of examples here, so I've got them all in one big file. Okay. Right. So when you do that, it replaces every period with a slash. Right? Notice that translate doesn't care about wildcards or anything like that, right? So it's not interpreting the star as the period as being any character, right? So you end up replacing all of the periods with a slash. Okay, now you can replace more than one character at a time, right? So the way you do that is you specify a full set of characters for from and to, right? And the way you do that, well, there's three ways you can do that. So you can use a sequence of characters. So this is the only portable. So this is the only way to do this that's guaranteed to be portable between different shells and different operating systems. Right? So you can spell out the entire sequence that you want to translate from or to. Right? So for example, I want to translate all uppercase characters to something else. Right? So that could be that's one way to do it. In Bash, you can use a range. Right? So you can write big A to Z. Right? That'll work in Bash just fine. It'll work in Bash if you're working in English just fine. If you're working in some other language, it may not work properly. And if you're working in some other shell, it's not guaranteed to work. So that's not portable across shells or operating systems. Alternatively, you can use the POSIX character classes. Right? So these are the same character classes that we used in regular expressions and wildcard matching. Right? These are portable across any POSIX-based system, which includes Linux. Right? So Linux and Unix, this will work. If you're on some other, and Mac, it should work too. If you're on some other variation of an operating system that's not necessarily POSIX compliant, this may not work. Right, so 1's the most portable way to do it. 3 is the second most portable way to do it. 2, it's only guaranteed to work in bash. Now, it's character by character, right? So your set from normally has the same size as your set to, right? And the way TR works is it takes the ith character in from, right, and replaces it with the ith character in to, right? So it's literally character by character translation. So for example, right, here's the string CISC220 where the CISC is in lowercase, right? I want to translate all lowercase letters to their corresponding uppercase letters, right? So if you try that, it's going to change the CISC to all caps. Oops, sorry. Oh, I didn't mean to copy. Right, and so that works just fine. Now, what happens if from and to have different lengths? Right? So if from is shorter than to, right? So in other words, you specify fewer characters to translate from, right? And that's fine. You just ignore all the excess characters in to, right? But if from is longer than to, right, then to is extended by copying its last character until to is the same length as from. But that really only happens in bash. So that's not portable across different shells or operating systems either. Right? So in bash, it copies the last character of to and just replicates it. Right? So for example, right, in bash, that first line, right, will take the numbers 0 through 9, right, and it will convert them all to x, right, capital X. Right? So when you run that, you're going to get CISC x, x, x. Right? And so what the program actually does is it takes that x and makes 9 extra copies of the x, right? So that the set to has the same length as the set from, right? So in other words, TR takes makes x, 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 right? 10 x's, right? Now that works in bash just fine. The more portable way to do this, right, is to not use a range. So instead, use a POSIX character class. Right? And then instead of writing x and then hoping that the shell or hoping that your TR program actually replicates the x is to use this funny notation here. So you put the letter that you want to replicate inside of square brackets and then you put a star after it. Right? So what the TR program does is it takes that x and then the star tells it to replicate the x as many times as it needs to in order for this set to have the same length as this set. Right? So that's the better way to do it. In this course, you can just use the first way, right? Because we're assuming bash in the first in this course. Right? And I mean, you can run this; it works, right? It just you end up with CISC x with all x's after it. Okay, now these are supposed to be sets of characters, right? From and to are supposed to be sets. In other words, they're supposed to be unique. They're supposed to contain unique elements in from, and the elements of to should be also be unique. So what happens if you don't use unique characters in one or both of the two sets? Well, the result is undefined, right? So if you actually read the documentation for TR, it doesn't tell you what happens if you duplicate characters, right? So for example, if I accidentally try to translate the characters CIS and then C again into CIS, right? So it looks like what I'm trying to do is I'm trying to take the little c, turn it into the big C, the little I, turn it into the big I, and the little s, turn it into the big S. Right? Now the question is you put this extra c in from, so what actually ends up happening? Right? And so what ends up actually happening in this case is as follows. Right? So if I run it on bash, or this version of bash anyway, where is it? Here. Right? You end up with the following result, right? Which is probably not what you were expecting, right? So let's see what's happening here, right? So I'm trying to convert the little c to the big C, the little I to the big I, the little s to the big S. And now I've got this little c here, right? And so what this version of tr has done, right? From is longer than 2, so it's taken 2 and replicated the last character of 2. Right? So in other words, 2 becomes CISS, right? And now when it does the replacement, right, it's chosen to replace little c with big S instead of little c with big C. Right? So in other words, it's chosen the last possible replacement for C, which is why you get CISS220. Right? But the results are undefined. So if you run this on a different computer, running a different operating system, or a different version of Bash, or some other shell, you may get some other answer. Right? So you have to be careful when you use this command that your sets are actually unique. Right? Okay. Now, tr does more than just replace. You can delete characters too. Right? So if you use the -d option and only the set from, then tr will delete the characters in from your string. Right? So for example, here I've got a date that's got a separator using the hyphen. Right? If I want to compress the date down to all numbers, I can just delete the hyphens. Right? So this is a pretty common operation where you end up deleting separators, right, to merge everything into one big word. Right? So tr -d, so delete the hyphen. Right? All the hyphens will disappear, and you'll get the string 20211004, right? All one word. Right? So if you want to delete a single character, or if you want to delete different instances of single characters, then you just change the set from, right, to specify the characters that you want to delete. Okay, and then sometimes you've got a string that's got repeats in it, right? So you have runs of the same character, right? So A, right? And you want to delete the duplicated characters, right? But you want to keep one of them, right? So you want to remove the excess, the repeated sequence, right? So you can use the -s for that. So -s will squeeze out repeated characters. Right? So here I've got a long run of A's, a long run of B's, and a long run of C's, right? I'm going to use the -s option to squeeze all the A's and all of the B's, right? But not the C's. Right? So let's see what happens when we do that. Here. Okay. Right? So you can see what it does is it removes the duplicated A's from the run of A's, right? And it leaves you with one A. It removes the duplicated B's from the run of B's and leaves the B, right? There's no C, so it leaves all the C's, right? So similarly, if you repeat the A's somewhere else and the B's somewhere else, right? It'll delete the duplicated run of A's and B's as well, replacing them with single A's and B's, right? So you're A, B, C, 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 A, B. Right? Now you have to remember that tr is a character-based editor. Well, not an editor. It's character-based. It works character by character. Right? So in other words, you cannot replace substrings. Right? So for example, right, if you have a run that looks like A, B, A, B, A, B, A, B, right, and you want to get rid of the last 3 A, B's, tr is not your tool. Right? Because what tr does is it removes the duplicated runs of A's and the duplicated runs of B's, of which I have neither in this case. Right? So this is not a substring replacing thing. It's character by character. Right? Okay, so that's the tr tool or command in 15 minutes. Right? That's basically, it doesn't do much else. It doesn't do much other than what I've told you. All right, now there's a bunch of other expansions that I didn't tell you about, and so some of these one of these expansions is very strange. The other ones are all they're all very similar. One of them's a bit odd. Okay, so these expansions are intended to handle empty variables, right? Or variables that are not set. Right, so you know in Bash creates the variable for you when you first try to use it, right? And Bash doesn't care if you use a variable that hasn't been defined yet, right? But the logic of your program probably cares whether or not something has been defined. Right? And so there's a bunch of expansions that let you deal with what happens when something's not defined or set. Something's not set or it's empty. Right? And so they have this I guess, slightly unusual form, right? So it's dollar, and then the braces, right? Parameter is just a variable name, right? So some variable name. And now you've got colon hyphen followed by a word, okay? So if the parameter is already set, right? So if this variable here is already non-empty and defined, well, so it's defined and non-empty, right? And then, right? Then that expansion just produces the string that's stored in the variable, right? So in other words, it just produces the value of the variable. Now, if that variable is not set or is empty, right, then that expansion produces the word. Right? So in other words, this whole thing ends up becoming just the word, right? But it doesn't change the parameter, right? So it doesn't do anything to the parameter. Now, sometimes, so that one's fine, right? So you can get, you can substitute in some other word if your variable is not set, right? A lot of the time, though, if a parameter is not set, you actually want to set the parameter to some default value. So that's what the second one does, right? So if the parameter is already set, that expansion just produces the value of the parameter, right? If it's not set or empty, right, then that expansion produces whatever's in word, right? And then it assigns word to the parameter, right? So that's the one you want to use when you have a variable that's possibly empty or not set, and you actually want to give it some default value, right? So that one's handy. The question mark is the weird one because it doesn't behave the way you think it ought to, right? So the question mark, if parameter is set, right? So if the variable exists and has a value, right? Then that expansion just produces the value of the variable, right? If it's not set or is empty, then you end up with an error, okay? And the error, it's weird. So if it's sent to standard error if you're writing this if you use this in a shell, right? In a script. So if you call a shell script and you're using this, then it gets sent to standard error. If you're actually trying to use this on the command line by typing something in, then the error actually goes to standard output, which is very strange. Right? Right, okay, so you end up with some error message. So this is basically a way of indicating that there's an error, right? So there's something that's empty or not set, and I can't do anything about it, right? And finally, the plus one sort of works the opposite of the other ones. Right? So if parameter is set, if parameter is unset or empty, right, then it does nothing, right, which is kind of weird, right? But if it is set, right, so if parameter is set, then instead of getting the value of parameter, you get the value of word, right? But parameter is not changed. Okay, so let's see these in action, right? So here's the minus, colon minus. Right? So this one's going to give you back word if parameter is empty or not set, but it won't change parameter. Okay? So here, foo is empty, right? It's not assigned. Right? Here, if I echo out that substitution, right, you'll get the string substitute. Right? And then when you echo out foo, you'll get the empty string again, or nothing. Right? So let's try that. Right, so let me just do the, okay, so I've got foo here, right? It's not assigned. I'm going to do the expansion here with the colon minus, right? Because it's not defined, I expect the word substitute to appear, and it does, right? I'll type these out again in a second, right? But foo is not changed, right? So there is the expansion, right? You get the word substitute, right? But it doesn't change foo. Okay, so if foo is defined, A, B, C, right? Then when you do the expansion, you just get A, B, C, because that's the value of foo, right? Foo is not changed, right? So that's good. Now, what about the next one? So the next one is the equals, right? So this one will actually assign a value to the variable if it's not defined. Right, so this one will do the assignment. So let me just do this. Okay, so here's So foo is not defined anymore. Right? I'm going to do the expansion with colon plus. Right? So this should produce the string substitute. And it didn't. Sorry, hang on. Did I type that in right? Oh, sorry, colon equals. Haha. Colon equals. Okay, that produces the string substitute, which it does. And the value of foo is now changed to substitute. Right? So that's the one that's probably the most commonly used one, right? When you have some, right, especially if you're reading in input arguments from the user, right? So you read in some input arguments, they don't give you enough arguments, so you want to fill in whatever's missing with some other value, right? Colon equals the thing that you want to use here. I'm going to skip over this one because this one's strange when you run it from the command line, right? This one, though, is kind of the opposite, right? So if the word is not set or empty, it does nothing, right? But if it is set, right? So if it is set, then you end up substituting word in its place. Right? So foo is empty. I'm going to use plus here. Right? So this should do nothing because foo is empty. So you get nothing. Right? And foo should be unchanged, which it is. Right? Now, when foo has a value, right, then this substitution actually does the substitution. Right? So now you get substitute, but it doesn't replace the value in foo. Right? Okay, so there are the 4 different substitutions that you can use when you have unset variables. Right? All right, now how about some string stuff? So strings are pretty fundamental to Bash, right? Everything's basically, every value in Bash is a string. Right, so it makes sense that you should be able to do some string manipulations as well, right? So hopefully you can get like the length of a string. You can do things like replace substrings or things like that, right? And you can, right? So dollar, brace, number sign, right? Followed by a variable name, that tells you how long a string is, right? Now remember we've seen this $@ expansion before, right? So we've seen that before when we talked about input command line arguments, right? And remember that tells you how many positional parameters you have, or in other words, how many command line inputs you have. Right? Instead of using @ if you use a variable name, it tells you how many characters are in that variable. Right? So hello, right? If you echo out $, brace, hashtag s, that gives you the length of s. So apparently that's 12 characters long, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, yeah. Right. So that's how you get the length of a string. Now how about getting a substring? So there's no indexing into a string in Bash, right? Which is a little inconvenient if you wanted to, for some reason, iterate over the characters of the string, right? So instead of using indexing, you kind of have to do the Python thing, and you have to slice the string, right? So in Bash, that's called getting a substring, right? So if you have a string stored in a variable called parameter, or sorry, if you have the thing parameter is the variable, right? So variable :offset gives you the substring starting at offset and going to the end of the string, right? Offset starts at 0. For the first character, right? So some variable name :0 just gives you back the entire string, right? Now, if you want part of the string, you can specify the offset, and then you specify how long do you want that substring to be, right? So for example, 0 and 1 would give you the first character of the string, right? 1 and 2 would give you the second character. 0 and 2 would give you the first 2 characters, and so on. Right? So again, lots of little examples. So S is my string A through J, right? Oh, you know what? Hang on. Let me do this. OK, there's S. OK, so S:0, that's just the entire string S. Right? So starting at 0, going to the end of the string. Right? 1, starting at the second character, going to the end of the string. Right? 2, right, starting at the third character, going to the end of the string. Right? I think this will work. -1 gives you, OK, so that didn't do what I was expecting it to do. You can use a negative index somewhere, and it starts at the back. But I'm not exactly sure how to do it because I've never done it before. But in modern versions of Bash, you can use negative indexing. OK, now what if we use the length? Right? So 0, 0, right? That second 0 means the string of length 0, so you get nothing. Right? 0, 1 means start at the first character, give me back the substring of length 1. Right? 0, 2, start at the first character, give me back the substring of length 2, and so on and so on. Right? So if you wanted to do 1, 2, that gives you the 1, 1. Right? That gives you the second character. Right? So that's essentially Bash's notation for slicing a string. Right? I guess it's kind of similar to the Python one. It's a little different. But it's the same. It's a similar idea. Right? So the Python one, you have to specify the end index. Right? Here in Bash, you specify the length. OK, so what about removing parts of a string? Right? So Bash lets you do some pattern searching to remove the front part of a string. Right? That's what I mean by leading. Right? So everything that's in the front. But it supports only a limited set of pattern matching. Right? So it doesn't support the full set of regular expression pattern matching. Right? So what it does is it lets you do the wildcard pattern matching. Right? So star for any character, right? Question mark, and so on and so on. Right? So if you do $, brace, variable name, £, followed by a pattern, right? That removes the shortest leading part of the string that matches the pattern. Right? Now, often you want to remove everything that matches the pattern. Right? So that's pound, pound, right? Or hashtag, hashtag. Right? That removes the longest leading part of the string that matches the pattern. Right? So single hashtag, shortest part of the string that matches the pattern. Both hashtags, longest part of the string. There's no way to specify something in between. Right? You either get to remove the shortest part or the longest part that matches. OK, so here's file.txt. Right? If I do star dot, right? Remember, star matches anything, right? And a dot, in this case, matches the period. Right? So don't get confused with regular expression matching. Right? This is now wildcard wildcard matching. Right? So star, anything, any number of characters, followed by a period. Right? I've got the hashtag here, so it's going to remove any number of characters followed by a period, and it's going to remove the shortest sequence that it can. Right? So it's going to remove file and the period to leave me with just txt. Right? That's going to do the same thing, right? Because there's only one pattern in this string that matches star period. Right? Wrong one. So there you just get the txt. Right? And if you do those two, you also get txt. Right? So that gives you the extension in this case. Right? Now, sometimes you have unusual file names where there's multiple, what appear to be multiple extensions. Right? So file.back, oh, sorry, file.back.txt. Right? So this is a backup file. It's a backup of a text file. Right? So you might have a file name like that, and you might have many dot somethings in between. Right? You don't often see this in Windows, but it does show up a lot in Linux. Right? So there's my file name. Now, if I just do this one, right? So, right, match any sequence of characters followed by a period. Right? There's only one hashtag, so this is going to be the shortest one. Right? So in other words, it's just going to remove the file dot. Right? So you're going to get back.txt. Now, if you actually want the extension, which is just the txt part, right, you have to remove the longest part from the front, right? And now you get the txt. Right? So that's how you get the actual extension of a file, right? If you want to get the true extension of a file, it's always hashtag star dot. Okay, you can also remove the trailing part of a string, right? So if I want to get the file name part, or what's called the base name of a file, right? I want to remove all of the extensions from the name of the file, right? So now you want to remove from the back part. So that's the % instead of the hashtag, right? So parameter %pattern will remove the shortest trailing part of the string that matches the pattern, right? % pattern removes the longest part. The longest trailing part of the string that matches the pattern. Right, so again, the same example, right? File.text. Now I want to remove the extension and the period, right? So I want to get what's called the base name of the file, right? Which is just the first part of the file name, right? So I want to get file in this case. So now I want to remove the .txt, right? Which I can remove by specifying dot, right? And anything else, right? So in the first case, so there's that, right? If I use the %, that will remove the .txt and give me, sorry, I always do this. It's .star. You have to flip the pattern around, right? So that gives you file in this case, which is what we want, right? % removes the longest one, which is just the txt, right? But if you've got multiple extensions, or what looks like to be extensions, right, then if you remove just one, you end up with file.back, right? And if you remove all of them, that's when you get the actual base name. Okay? So there's removal at the front and back. Still can't remove from the middle, though, right? So to remove from the middle, you may have to, you might be able to use this, this following notation, right? So you can replace a substring inside of a string that matches a pattern. All right, so this one will actually replace an entire substring, right? So unlike tr, which replaces single characters, right? Now you can replace entire substrings, right? So it's variable name / pattern / string, right? So string gets substituted in for the first occurrence of pattern, right? Only for the first occurrence. If you want to replace all occurrences, then it's / in front, but not in the back. Right? So / pattern / string replaces all substrings that match the pattern with string. Right? So this is how you do substring replacement. So there's my string, right? Again, lots of p's, right? S/p/t replaces the first p, right? So you get starring with a purple porpoise, right? /p/t replaces all occurrences of p with t, right? So now you'll get starring with a turtle tortoise, right? Now, it'll do substring replacement, so the length of that does not need to match the length of that, right? So it will do full substring replacement. So in other words, wait, I guess I'll do deletion first. Well, hang on, I'm going to come back here. Oh, no, I guess I'm not coming back. I think what happened was I included it as an example. Okay. Right here. And just a second here while I do that all over again. Okay, so here's my string. Right, now here's my replacement. I want to replace all occurrences of spar r with talk. Right, so these two strings, they don't have to be the same length. Right, and when I do that, right, it replaces the front part, the SPARR, with talk. Right? Now you get talking with a purple porpoise. Right? So those strings don't have to be the same length. You get full substring replacement. Right? Finally, that last part there, that's the last string, doesn't need to be there at all. Right? So if string is omitted, then deletion of the substring occurs instead. Right? So S/p/ removes the first p from the string. So S/P, right? You'll get sarring with a purple porpoise, right? If you want to remove all the P's, it's //, right? And now you get sarring with an Earl or Oris, which is hard to say. Okay, and finally, we've got our case conversions. All right, so I think for most of you, case conversions are going to be a little weird because you'd ask yourself, why do you want to convert? If you have strings, why are you converting their cases to something else, right? So the reason you do case conversion in a lot of programming, especially when you're accepting user input, it's called normalizing the input, right? So if you get some string from somebody, it's very common to either to turn that string into all caps or turn it into all lowercase, right? And so that's so that you always know what the case of the words are that you're working with, right? So for example, if you're looking something up in a dictionary, you don't want to deal with the case of the words, right? So in that case, when you take the word, you just turn it into all lowercase or all uppercase, and then you look it up in the dictionary. So Bash has these 4 conversions for you that do nothing but case conversion, right? So it's really weird, right? So comma, comma, right, expands to that variable, expands to the value of that variable in all lowercase, right? Comma expands to the value of that variable, but it only converts the first character to lowercase, right? Caret, caret converts everything to uppercase, and then the single caret converts just the first letter to uppercase, right? I see lots of people jotting this down, so I'll just wait for a second. Right? So comma, comma, all lowercase, comma, only first letter to lowercase, caret, caret, all uppercase, and then caret, only the first letter to uppercase. Right? So here's a string in camel case, right, which is what you would be writing in Java. Right? If I do S, comma, comma, you're going to get everything in lowercase. Right? Wrong one again. Okay, so there's S, right? There's the substitution, right? S comma comma, so that's going to do everything in lowercase. That doesn't change S though, right? So, right, S is still camel case, right? This is just a substitution, right? So it doesn't actually change S. If you want to change S, you have to write S equals that, right? So you have to reassign back to S, and now S is in all lowercase. I want that one back again. Okay. Okay, so that's the comma, comma. If I just do a comma, right, that's only going to convert the first letter. Sorry, I messed that up. S equals that, and then I want to do echo dollar blip, 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 blip. Sorry, there. Okay, right. So that converts the first letter to lowercase, but it's already in lowercase. Right? Right, so the double caret, everything goes to uppercase. Single caret, first letter goes to uppercase. Right? You would most often be using the double caret and the double comma, right, when you want to normalize input. All right, I think that was it is the last slide. So that's pretty much all that we're covering in Bash for the first part of the course, right? In the second part of the course, every once in a while we'll come back to Bash when it makes sense to come back. But now we're switching to C. So starting on Friday, you'll get your first introduction to the C programming language. Right? Everybody's taking 124, right? Yes? Okay, that's good. So C, the core C language looks a lot like the Java core language. Right? So we don't have to spend much time talking about loops and if statements and stuff like that.